In this MicroNugget, we're going to take a look at how to implement a DHCP starvation attack. Now, with any type of an attack tool, we would never want to use any of these tools in any unauthorized or illegal ways. So having said that, let's jump in. To really appreciate a DHCP starvation attack, we got to first make sure we're comfortable with the basics of DHCP. When a PC boots up on the network, if it's a DHCP client, it's going to issue a DHCP discover packet. It's effectively saying, I'm looking for a DHCP server, a dynamic host configuration protocol server that can issue me an IP address. So here's our client, and over here is the server. Now, if there is a server that hears that request, it's going to send over an offer. And in that offer, it's going to offer an IP address that the client is allowed to use. Now, the DHCP server has a pool of addresses. On a /24-bit network, the maximum number of IP addresses that could be in a pool would be 254. It's also very likely that a few of those addresses are saved for things like static router addresses and so forth. So the pool of addresses may be only 252 or 253 addresses at the most that it can hand out. And in this offer, it's just offered to give this client one of those IP addresses. The client, when it gets that offer, sends a message back saying, yeah, I'd like to request that IP address that you just offered me. And then to finalize it, the server sends over an acknowledgement that confirms to the client and anybody else who's listening that this client is now going to use an IP address assigned by this DHCP server. So that's the 4 packets involved: discover, offer, request, and acknowledgement. That's the 4 basic packets that we'll see quite a bit. Now, in a hostile environment where we have a malicious machine running some kind of a tool like Yersinia, we could have this machine send in DHCP discovers, and this malicious client could send hundreds and hundreds of these malicious discover packets using a bogus made-up MAC address as the source MAC address for each of the requests. And if the server responds to all of them, it's going to tie up all the IP addresses that this DHCP server has to offer. And then once this server has no more IP addresses to offer, the next thing to typically happen would be the attacker would bring in their own DHCP server as a rogue DHCP server and now start handing out IP addresses. Well, what's the benefit of that? Well, if the attacker device can now hand out IP addresses, including default gateway and DNS information, clients who use those IP addresses and start to use that default gateway can now be routed through the attacker's machine, and we've just accomplished a man-in-the-middle attack. So in this MicroNugget, I just want to focus on how simple it is to launch the first part, this DHCP starvation attack. And to do it, we'll use Kali Linux and a little application called Yersinia. Now here's the play-by-play for this. I've got this little Raspberry Pi, and its Ethernet cable I have plugged in physically to port number 2 on a switch. On port number 3, it leads off to the DHCP server. And what we're going to do is use Yersinia on this Raspberry Pi, which has a special version of Kali Linux made for the Raspberry Pi. And using Yersinia, we'll go ahead and start a DHCP starvation attack. Now, if you're curious about how I have this set up, I've got my Raspberry Pi. It has a little wireless adapter. And I've got an SSH session going to this Raspberry Pi that's running Kali, and I'm connecting to it over the wireless. The Ethernet port, which is Ethernet 0, I have physically connected to port number 2 on this switch. And that way I have out-of-band control of this device, and I can launch the attacks over the Ethernet interface. I've also got my terminal emulation program, which is Secure CRT, configured as part of the SSH session to do X11 redirection from this Kali box back to my computer, which makes it really easy for me to demo it. I'm also running Xming, which is an X11 server, on my host computer, which is Windows 8. So let's go ahead and launch Yersinia with Yersinia-G. That'll launch the graphical version of Yersinia, which will pop open as an X Windows interface on this computer. And let's also go over to the router while that comes up. So here's Yersinia. And on the router, let's do a couple things before we launch the attack. Let's do a show IP DHCP binding. This will show us any IP addresses that we've currently handed out from this DHCP server. And at the moment, it hasn't handed out any IP addresses. We could also use the command show IP DHCP pool just to get an idea of what pool it has available. So in the pool called DHCP pool, it has the range of 10.123.0.1 all the way through 254. And at the moment, it hasn't handed out any IP addresses. But that's all about to change once we launch Yersinia. So back at Yersinia, we're going to click on Launch Attack. And we'll go ahead and choose DHCP. And in our case, we're going to send a whole boatload of DHCP discover packets. Now Yersinia, which is included as part of Kali Linux, which is running on that Raspberry Pi, As it sends out Discover packets, it's going to send out thousands of Discover packets, and it's going to create some bogus MAC address for each one of them. So the DHCP server just thinks he's getting bombarded with all these requests. And we'll simply click on OK to launch that attack. Now, if we look right here in this column regarding seconds, you can see those seconds are incrementing. That's the history of the Discover packets that we're sending out. We're sending out hundreds and hundreds and hundreds of Discover packets. So now that we've let that run just for a few moments, let's go ahead and click on List Attacks. And it's currently showing that we have only one attack running at the moment. So we can click on Cancel Attack or Cancel All Attacks. Either way, it's going to cancel the DHCP Starvation attack. So now with that attack canceled, my screen is still catching up, updating the log events regarding what has happened. So back on R1, who's acting as our DHCP server, a few moments ago, it hadn't issued any IP addresses to clients. But now, if we do an up arrow key and do a Show IP DHCP pool, the router's saying, oops, I'm so sorry, the database couldn't be locked. It's so busy right now in dealing with all those DHCP requests, it can't respond to our request. So we'll give it a few seconds and then hit the up arrow key and let's try it one more time. So here it's currently showing that we have 79 IP addresses that have been leased. If we left Yersinia running with that attack in the background, it would indeed consume all the IP addresses in that pool. And just for grins, let's hit the up arrow key one more time just to confirm that that number is not changing. Now if we wanted to see the details of those IP addresses that have been handed out, we could use the command Show IP DHCP binding, press enter, and there's going to be several pages of IP addresses that have been handed out. And all these MAC addresses, they were all made up by the Kali Linux box and Yersinia as it was sending out those Discover packets looking for an IP address. Now the challenge is, when the DHCP server has handed out all of its IP addresses, what's going to happen when a new DHCP client who wants an IP address or needs an IP address comes on the network? The answer is DOS, a denial of service. There won't be any IP addresses available. And that's why very often, following a DHCP starvation attack, the attacker will come in with their own DHCP server to start handing out IP addresses. And that leads to additional compromise of our users' traffic, especially if the attacker has now pulled off a man-in-the-middle attack, where all the traffic from our devices, as it's trying to leave the subnet, is going through the attacker device. And that attacker is now a man in the middle. Because this type of an attack is so easy to pull off, what could we possibly do to help mitigate the risk? And the answer to that is we could mitigate this type of an attack with something called port security. And because this is a MicroNugget, I want to keep this short, we'll cover port security in another MicroNugget. Meanwhile, if you have interest in Kali Linux or Backtrack, come and check out our penetration testing with Linux tools course at CBT Nuggets. And if you're interested in how to protect against the attacks that can be launched by Kali Linux in a Cisco environment, you may want to come and check out our CCNP security track, also at CBT Nuggets. And if you don't yet have a CBT Nuggets membership, no problem. We have a free 7-day trial, which gives you full access to our IT library, so you can go ahead and have a first-hand experience in checking out these videos. I've had a great time, and I'm glad that you joined me for this MicroNugget. I hope this has been informative for you, and I'd like to thank you for viewing.